Today is Sunday, September 27, 2015, and we're going to have a very, very interesting weather pattern setting up over the next week or two. And this weather pattern will set up courtesy of a tropical disturbance right now that is off the coast of the Bahamas, just west of the Bahamas. That is just east of the Bahamas. And this is the one that will add moisture to our cold front that's going to come in from the west. The cold front will come through Tuesday night into Wednesday morning. It will also get additional moisture from another tropical system that's currently in the Gulf. It will probably not be named. It will probably just be, inconspicuous blob of moisture with a weak area of low pressure, which the cold front will absorb. Here's a cold front coming through, which is visible by this 577, which is visible by this 5700 line. That is actually tropical, the freezing level at about 700 millibars. This is the freezing level at 700 millibars, or at 500 millibar freezing level, I believe. I'm sorry. See? So the 5700 line will likely be the freezing level, I think around 600 millibars, and this is the freezing level at 850 millibars. The 5700 line, which indicates a cold front, basically, the one that's moving eastward. See, that's a cold front coming through. So we'll clear through New York City about Wednesday morning. You'll think you're probably in the clear, so, everything's good, right? Well, remember, there's going to be a tropical system here. There's going to be a tropical system here. Well, just remember, there's a tropical system here. There's another tropical system here. And, of course, there's a cold front. But also, what I didn't factor earlier was a cutoff flow. And this cutoff flow is made visible by some moisture here. See this? That's another cutoff flow. That's going to be that link in the chain which will set the whole thing in motion. This right here. What does it look like? A few sprinkles, right? Yes, but look at aloft. Look at temperatures aloft. This is at hour 90. This is what's going to happen. See? Cold air aloft. Cut off. Here's a jet stream. And then look, it's going to cut off itself and just spin, and it's going to spin right down into the Tennessee River Valley and the Mississippi River Valley. Guess what? It's going to move eastward. And as it does that, it's going to pick up that area of low pressure that will form and force it to go north and west because of the flow aloft. Pretty crazy, huh? Just look at this. So here is that area of low pressure, which will form, mostly due to this high pressure system to the north, which will kind of create a coriolis effect, which will set the thing, everything in motion. Because a soft frontal boundary, you have winds going west and southwest, south of the front, and winds going northeast north, because of the high pressure system to the north. And then, as it goes over the Gulf of Mexico, the pressure will deepen. Because of the Gulf Stream, warm waters, the low pressure will deepen, and a wave of low pressure will get stronger and stronger and stronger and stronger. And guess what? It will also cut off itself from the jet stream. And looking aloft, it's going to be tropical in nature. You see this right here? See this little blob of moisture right here? That's what we need to watch. See, it's going to come right into New York City. Whether it breaks off itself or whether it comes ashore remains to be seen. But anyway, we're going to get a lot of rain in New York. And then it's going to lose its tropical characteristics once it, reaches the coast, because the water's going to be cool. You're going to have dry air circulating through the system. This will be kind of a hybrid type storm. So Monday you're going to have kind of a cold air loft, showers and thunder showers. Now Monday you're going to have a lot of cold air loft, so whether there's going to be a lot of cold air loft or a little bit remains to be seen. But anyway, we're going to have some convective showers Monday, according to this run of the GFS. So now I'm looking at what's going to happen in terms of convective, precipitation. This is going to be more like thunderstorms and convective showers. Tuesday and Wednesday, we may get some thunderstorms Tuesday night. We may get some, boomers. And then, the weather clears up, but that's only for a short time. Because, of course, you get this forming. You get this little tropical system forming. And you know what tropical systems usually have around their center? Thunderstorms. But this tropical system will have thunderstorms mostly on its northeast side. Because on the west side, you're going to have a lot of dry air, but you could still have some convection, on its west side. But it'll be mostly on its north and east side that's going to have the most convection. And it looks like New York City isn't going to get much convective weather. Maybe on Long Island, you may get some squally weather Sunday afternoon. And then Monday, as I said, it's going to mostly clear up. But because there's going to be some cold air loft, you could get a little bit of some convective showers, but not really much. What to look for cold air loft is at 500 millibars. Remember I said there'll be cold air loft coming out of the Midwest through Canada? Monday, here's a cold air loft that's going to be over in the Northeast. It will definitely be over in the Northeast Tuesday. I think Tuesday is the real day for the real cold air loft. But the low pressure itself will be further to the northeast, which means and the showers and thunder showers associated with it should also be to the north and east. Also, Tuesday should be a cooler day. I mean, this is way, going out almost 2 weeks out. So, this is almost going out 10 days. It'll be the following Tuesday. See, cool temperatures in upper 60s, low 70s. Even Monday, I think, will be a pretty cool day. Temperatures only in the 60s, but Sunday will also be a stormy day. Saturday will be stormy. I mean, look at this. Saturday, Sunday, Monday. It's going to be a 3-day event of just rain, and clouds. I think Friday will be the best day, honestly. Even Friday, wow, it's going to be cool. Oh, my goodness. Woo, boy, it's going to be bad. I think the warmest day, will honestly be Monday. Tomorrow will actually be the warmest day. Monday, Tuesday will be a nice day, warm, and then Wednesday, the cold front comes through. Thursday, cool. Friday's going to be cool. Saturday's going to be cool and stormy. Sunday's going to be, stormy. I mean, and then Monday's going to be an day. Tuesday's going to be the first nice day, but it'll still be cool. Wednesday, I don't know. Oh yeah, see that? I don't know what's going to happen with that. But look at all this cold air. Oh my goodness, that's a lot of cold. I mean, that is going to be frost and freezes. Wow, that is cold. But that's going to be mostly the surface. I don't know how it's going to be aloft. Aloft, it's going to be pretty cold. There's probably some snow showers, maybe some grapple showers. Looking for the winter, I don't think we're going to get much. If that tropical storm forms, it's probably going to be Jacqueline. Tropical storm Jacqueline. Jacqueline, yeah, that's a pretty, name I haven't heard of much. Oh yeah, 2017, we're gonna have a name Irma to replace Irene. You know what's so funny was, okay, because I'm a fan of a TV show that no longer exists. I used to be a fan of Witch, and Irma, was a character who had power of water. I said, okay, I just made up a term called Tropical Storm Irma. But it was after Irene hit, and then look, boom, they said Tropical Storm Irma for 2017. Okay, that's kind of funny. But that happened, I think, about 2 years ago. So yeah, Jacqueline, Ida, the ice storm curse is over. Ike, Ivan, what else? Isaac. Yeah, the ice storm curse for now is over. We've also been hit by a lot of F storms. Francis, Floyd, and some J storms have been pretty bad, like Jean, have been pretty bad. I mean, but, you know, because I is usually in the middle, that's where you get a lot of ice storms, you know, during active seasons. During non-active seasons, it's usually C and A's that are really bad. Like we had Hurricane Alice in Texas in 1983, Hurricane Andrew in Florida, Hurricane Bob in 91, Hurricane Bill in Texas, or Hurricane Bill in, not Bill, Claudette, Camille. Usually the really bad storms are usually the first several storms in a non-active season. You know, late season storms are usually really bad on this one. And in an active season, it's usually I that are really bad. G's are also pretty bad. Like Gloria's 1985 storm was pretty bad. Then you had Gustav. You also had another one, Grace. You know Grace? 91 actually formed the perfect storm. You know, ever heard of the perfect storm? It actually was a hurricane. It should have been named Henry, but the National Weather Service decided not to name it. Had it been named, it would have been named Henry. It was a hurricane because it had a warm core. It formed in the Gulf Stream. Even though it had an eye, had thunderstorms around it, Hurricane Hunter's planes found a warm core. They didn't want to cause a panic because, you know, already hurricane force winds reaching the coast. Now, of course, we would have named it. We would have. The perfect storm was essentially a Sandy Lake storm. But yeah, to avoid a panic, they didn't want to name it. This will definitely not be a storm like that, but it will have a lot of winds with it. This is wind speed at 925 millibars, which is around 2,500 feet up, basically. About a little shorter in height than the tallest building on Earth, which is almost 3,000 feet tall. So this is winds in knots. Of course, this is where you get hurricane force winds. 50 to 60 is, you know, strong tropical storm force. 60 to 70 is where you get hurricane force. 65 knots is hurricane force. That's where you begin to get into hurricane force wind criteria. But these are winds aloft. So these winds here are about 35 knots. These are about 40 mile per hour winds aloft. This is not surface winds. These are aloft. So these are winds at about 2,000 feet up. So a plane will probably have a difficult time landing. Like what if it's coming from the, going straight down, because you're going to have some crosswinds. See, strong northeast winds. Probably at surface level, probably be 20 to 25. Probably have gusts up to 30 knots at ground level. Of course, the winds will definitely not be as high as 925 millibars at ground level. We probably have winds 25 to 30 knots at ground level. Then look, as our tropical system begins forming, guess what? Here it begins to form. You get a little bit 50 to 60. Looks pretty exciting, right? And look, it gets even more exciting. Boom! Look at that! Wow, just look at that. That looks exciting. That is... Oh, there's some hurricane force here, look. So you got level 1 color in red, level 2 color, even a little bit of level 3. There's 1, 2, 3. That's over 79 winds. That's still a minimal hurricane if it were a tropical system. This is aloft. Sandy, oh, we were all the way up to 80 to 90 knots, at that level. We were, forget about it, Sandy was one big storm. And because this is not going to be a tropical system, this will be more of a, this will because of pressure gradient. This is where you have the greatest pressure gradient. So 700 millibar temperature, it's about 156 hours out. It's about one of the worst weather will be hitting New York City. Okay, see? This is wind speeds at surface. See? That's why the storm will be coming towards us. The center of the storm will be here. The worst weather is always, for these tropical storms, always north or west or east of the center. Not directly, around it. Like, it'll be more away from it. So you'll have about 2 days of good weather. From about hour 96, will be pretty good. Not 2 days of good weather, about a day actually of good weather. We'll have about 1 day of good weather, and then, 2 days of good weather, and then it goes downhill. Wall of Let's see. So the rain will end around hour 93. That's when it clears out. Even though it clears out, you're still going to have northeast winds. You'll probably have some drizzle along the coast. It's not going to be a pleasant beach day at all. I mean, I wish I could find cloud cover. See, precipitable water. Pretty high along the coast. I mean, look, we're really not ever going to get out of the precipitable water index. And actually, it's just going to come back up as a tropical system forms. So, I don't know how much we're going to get from the storm, but probably get a good amount. This is actually going to be in precipitation. This is what the thunderstorms are going to get. So most of the rain, according to this model, will be from the thunderstorms. And then, boom! Even more. We definitely need this rain because we're in a drought right now. So I'm going to type up drought monitor. Just a few days ago, they were forecasting nothing for New York City at all. Yeah, we're in a pretty bad drought right now in the Northeast. Bad as in, for Northeast. Not bad, Northeast are not used to drought at all, so the fact that we're in SL, which means short to long-term drought, it's not good. Yeah, it's pretty bad. See? The entire New York City metropolitan area is in a moderate drought, as I said. So, to get moderate, to severe, to extreme, to exception. I mean, just look 3 months ago, no drought was about 60%. Now it's only 37.33%. See, slowly but surely, the no drought is getting smaller and smaller. More of the New York City area is becoming covered in drought. Even New England is in a drought now. Every part of Connecticut is in a drought now. Look at that. Huh. Every part of Connecticut is in a drought. D1 is, slowly but surely, just being taken over by D1 to D4. That's not good. See, D0 to D4 is 100%. Look, already almost two-thirds of Connecticut is in moderate drought. I mean, that's not good. I mean, look at California. So compared to them, we're doing pretty good. Texas is in a short-term drought. This is S, which means short. Texas was in extreme drought here. They essentially wiped off their drought, but now look, you get a pretty extreme drought in southeastern Texas. Yeah, looks like again, Texas gets flooded and then they go to another drought. They cannot, just get out of this pattern right now. Well, that's good because it's gonna get some rain. Okay, you know where Texas needs the rain? Here. They don't need it here. Why? They do a little bit. Yeah, they do need a little bit, but really all of Texas needs rain, not one part. Here's the tropical system that's forming. Wow, I mean, look at that. That's gonna be a lot of rain forming right here. Oh my goodness, that's gonna be a foot of rain forming right around the storm. Well, it's gonna be from. I mean, in the Northeast, I just want to go right back to the Northeast, see exactly how much we're gonna get. Wow, 5 inches of rain possibly, because I see some purples here. Wow. So in 10 days, we're gonna get a lot of rain. Let me see how much most of it will come from that storm. So let's see. Supercell composite to see if there'll be any rotation of these storms come through. And no rotation really. I mean, they're saying there might be, but because see wind shear, see winds from coming from here. Okay, lapse rates. That's what you want to look at. Really, when you look at is the lapse rates. That is a real good indication of rotation, I think. Or I think lapse rates. No. Supercell composite. Its only reason it's low because the mu cape is going to be low. The convective available potential energy will not be that high. Yeah, that's what you want to look at. Yeah, that'll be pretty low. Oh, see, we're going to get clipped a little bit. Oh, yeah, going into winter temperature, winter weather forecasts. Okay, here's what I want to show you. Okay. I'm going to show you SST anomaly page for the whole world, the sea surface temperature anomalies. And right now what they're showing is we're kind of in a mixed situation for winter storms. Why mixed? Because I see some cool waters here, but also a lot of warmth here. This also sends a mixed signal, because you could have, if this becomes cool and this is warm, what will happen is you get a lot of tropical rains coming in the northeast all winter long. Just a lot of rain, subtropical jet. And the only snow you'll get is maybe on the northern fringes of these storms. You can get a little snow. But if this is going to be warm, and you get the polar jet to combine with the subtropical jet, which is very active during El Niños, you could get a major winter storm. One such year was 2009, 2010. Another really good El Niño year was 02-03. 02-03 was also an El Niño year where we got a lot of snow. I mean, a lot. New York City, I think, got close to 50 inches of snow. But it wasn't from like one, it was like from a couple of very, very, very powerful storms. I think that was the first time New York City got almost 50 inches of snow in a long time. 2002, 2003. No, not 2000. 2002, 2003. I'm doing it again. Okay. So 2002, 2003 was a very, very snowy winter for New York City. Well, that, in terms of like snowstorms and blizzards, yeah, it was. C, we had a weak El Nino forming. You can tell by how the waters are off the coast. They're pretty warm. And then going into winter, guess what? The El Nino intensified. And you had a little bit of warmth off southeastern Alaska, which created the positive PNA, which allowed the storms to form. Also, you had a little bit of warm waters here. You know, warm waters here means you have a positive or negative NAO. That allowed a lot of storms. But one of the craziest winters I remember, of course, was the winter of 14 and 15. That was just an abnormal winter. How did it get so crazy? Okay. End of December, we still didn't get a lot of snow. That's because the NAO was mostly positive. Yes, the PNA was perfect in terms of snow. I mean, except in December where it got a little positive briefly. But this is where it became positive about. But the NAO was mostly positive the whole winter, which means, or neutral, which didn't really allow for a lot of snow. Once we got into January, just forget about it. This is where all hell broke loose. January, February. Why did we get a lot of... even though the NAO was mostly positive, look at this very warm water here. Just look at that. That is why we had so much snow. The anomalies were just abnormal off the East Coast. Especially right here. And look how sudden it went from warm to cold. Just flipped like crazy. February was another crazy month. See? And then especially here. So when storms pass over that, they just blew up. They just went boom. Especially right over the Gulf Stream. This is the Gulf Stream. But see, the Gulf Stream, instead of going east, it really just collapses. Like right about here. That's because of too much polar ice melting. You know, polar glaciers, the ice caps, the glaciers, the sea ice, it's all contributing to that. And of course, towards the end of February, no matter how much storms we got, that anomaly just couldn't go away. And they tapped that anomaly. You had Clipper systems that actually, a Clipper system turned into Winter Storm Janice last year that just dropped feet of snow in Boston, like 2 feet. That entire winter in Boston I think was the snowiest winter they've ever seen in recorded history. Even though the NAO was not positive. I mean, not negative. The storm blew up so quickly that it actually cut off itself from the jet stream briefly. And allowed itself to just, really just go bonkers. Sometimes you don't need a blocking pattern to have a storm to stall. Sometimes a storm's own deepening can do that. Sometimes a perfect scenario could be the jet, a subtropical low combining with a polar jet. Clipper system combines with the a coastal storm or a Gulf of Mexico storm, and you get this all-out blizzard. I remember, I think President's Day, the post-Christmas snowstorm of 2010 was a storm like that. Why that was so intense. That winter was a little different. How? 2010, 2011 was another crazy winter. That year, how was it different was, guess what? The PNA was the Pacific Decadal Oscillation was mostly positive. It was very cold, which means a very negative PNA. But guess what? The NAO index, the Atlantic index was very warm, which allowed for a lot of blocking. So any storm that formed was mostly, rerouted around because the blocking high was very strong. Any storm would, just go up the coast, basically. And it really didn't have anything to do with this. Of course, if this was warm, it could have been even crazier. But, it wasn't. 2011, 2012 was a very, very warm winter. If you remember that winter, we got hardly any snow. And of course, you can see why. The NAO is not that warm. Also, end of December. Look at the end of December. And look at both the Atlantic and the Pacific. See how much cooler it is? That's why we didn't get a lot of snow. There's barely any warm here. Look at that. It's mostly cold. I mean, look at all this cold waters here. That's why we didn't really get a lot of snow. See that? All this cold here, all this cold here. Just as bad as it can get for snow. See this? This usually means there's a ridge here. Trough. That's why it was so just warm. You didn't get a lot of snow. The biggest storm we got, I think, was like maybe 6 inches of snow. The biggest storm was actually in October for some people, yeah. This is when we got a big, big snowstorm. And guess what? The NAO was actually warm at that time, see? And it suddenly flipped from warm to cold. Sometimes you could get cold to warm. That's pretty unusual. A good snow year was 1999, 2000. We got an okay amount of snow that winter. We had a pretty big snowstorm in January that winter. But it wasn't too bad. I mean, see, it was a little warm here, but it was mostly cold. We were in an El Nino that winter, 1999 to 2000. January, I think it was late January, early February. We had a lot of pretty bad snowstorm. Okay, well, I gotta go now. Well, thank you for watching. My forecast for this winter is not official yet, so I'm not going to make another winter forecast until at least the end of October. Well, thank you for watching. Have a great day.